Good morning. So in this class we are going to see some of the parameters that are related to study the performance of an antenna like gain, efficiency, effective length, effective area, aperture area, etc. So what is gain? So you know that gain means that is a ratio of output parameter divided by input parameter. So here since the antenna is used to radiate the electromagnetic wave, so the gain of an antenna has been defined as the ratio of radiation intensity in the given direction to the radiation intensity that would be obtained if the power accepted by the antenna is radiated isotropic, right? So you assume that the given antenna is isotropic. So if this is assumed as isotropic, what will be the power radiation or the radiation intensity received from this antenna? Based on that parameter as a reference, we have to calculate the radiation intensity of the subjected antenna. That ratio it is called as gain. So how much power is transmitted in the direction of peak radiation to that of the isotropic source. So that is called as the gain. So we have taken the isotropic source as an antenna to study the property or the gain of the subjected antenna. It is mathematically defined as G. It is a representation for gain that is equal to eta E and D, where eta E is the antenna efficiency, which is also we are going to see, and D is the directivity of antenna, which is also we are going to see. So this is the fundamental about the frequency and wavelength. So the difference between the frequency and the wavelength is given here. So what's wavelength? That is the distance between the two consecutive maximum points or the distance between the two consecutive minimum point. It is called as the wavelength. You know what is VSWR and reflected power. So the VSWR, it is nothing but the voltage standing wave ratio. It is a ratio of maximum voltage to the minimum voltage in a standing wave, which is called as VSWR. So if the impedance of an antenna does not match with the source antenna, does not match with the load antenna, then the power will be radiated. You will be having the reflected power, right? So next, bandwidth. We used to calculate the bandwidth as the difference between the upper frequency minus lower frequency. This is in general for all the electronic components, and it is also called as the absolute bandwidth, right? So here for antenna, here if you want to calculate the bandwidth, the ratio of absolute bandwidth to the center frequency of that bandwidth has to be taken as the antenna bandwidth, right? So the antenna bandwidth calculations must differ from other electronic components. So for any electronic component, it is nothing but the absolute bandwidth, which is equal to FH minus FL. But for antenna, it is nothing but the percentage bandwidth, which is a ratio of absolute bandwidth divided by the center frequency or the resonant frequency, which is given by this formula. So FH minus FL divided by DFC or the center frequency or the resonant frequency. The ratio is called as the percentage bandwidth or percentage bandwidth or fractional bandwidth of the antenna. Then radiation intensity. So in general, literally we know that radiation intensity, it is nothing but the power per unit solid angle. Power radiated per unit solid angle. So the radiation emitted from the antenna can be defined or can be represented in terms of radiation intensity only. So the radiation intensity, it is represented by capital U, that is equal given by R square into WRAD. That is WRAD, it is a power radiated, where R is the radial distance and U is the radiation intensity. And next, antenna efficiency. Generally the efficiency means that is the ratio of output parameter divided by input parameter, like gain. So here the antenna efficiency, it is the radiated power of the antenna as the output to the input power accepted by the antenna, which is given by this formula. Eta E is equal to power radiated, that is output power from the antenna, and the incident power to the antenna, that is a P input. So P radiation as the output divided by P input as the input power. The ratio, it is called as radiation efficiency. Now what is directivity? The ratio of maximum radiation intensity of the subjected antenna to the radiation intensity of the reference antenna, where we have to take the reference antenna as the isotropic antenna, right? Radiating the same total power is called as directivity. Listen here. So the ratio of maximum radiation intensity of the subjected antenna or test antenna to the radiation intensity of the isotropic or reference antenna radiating the same total power, it is called as the directivity, or the ratio of radiation intensity in a given direction from the antenna to the radiation intensity averaged in overall direction, it is also called as the directivity. So the formula for directivity it is equal to maximum radiation intensity of the subjected antenna to the radiation intensity of the isotropic antenna of the same power, which is represented by capital T, which is given by this formula. And what is aperture efficiency? Antenna efficiency we have seen already. So that is the ratio of the power output radiated divided by the power incident input. So P radiation divided by P input, that is equal to antenna efficiency. Here this is the aperture efficiency, where aperture efficiency of antenna is the ratio of effective radiating area to the physical area of the aperture. So there are here, this is a ratio of the two areas, that's why it is called as aperture efficiency, which is represented by epsilon A for aperture and epsilon for efficiency. It is given by the ratio of AEFF divided by AP, where EFF it represents the effective area and AP it is represented physical area. So physical area means it is actually the total area depending upon the dimension of the particular tested antenna, where AEF it is nothing but the effective area, right? So we are going to see what is the meaning by effective area. So keep it in mind that effective area is different from physical area. So when we take the effective to physical, it is nothing but the aperture efficiency. Now, what is the effective length? Antenna effective length is used to determine the polarization property or the efficiency of the antenna, which is given by the ratio of VOC divided by EI. VOC divided by VY, where VOC it is nothing but the open terminal voltage divided by the magnitude of field strength of incident wavefront in the same direction of the antenna polarization. Now, what is effective area? Effective area is the area of receiving antenna which absorb most of the power from the incoming wavefront to the total area. You keep it in mind that the total area of antenna cannot be used for effective radiation or emission. Only the portion of the total area has been used for power emission. That portion of the total area it is called as effective area, which is represented by AFF. Right. So far we have seen what is the meaning for the basic, what are the different parameters of the antenna. So next class we will continue some more parameters. Thank you.